Hello and welcome back to the classes by Mrs. Munisha Nagpal. We are back today with a new topic, new energy, that is ratio. Suppose A and B are two friends, okay? Age of A is 9 years and age of B is 12 years. Now, if I say compare the ages of the two people, A and B. So some will come up with an answer. Ma'am, A is 3 years younger than B, or you can say B is 3 years older than A. So this comparison you are doing by subtraction. Okay. Now some will say, ma'am, okay, now this is one way of saying. Now if I say A and B are two people, say A gets a pocket money of rupees 500 and B gets a pocket money of say rupees 3000. So if I say compare the pocket monies of the two people. So some will say, ma'am, A gets A's pocket money is rupees 2500 less than B, or you can say B's pocket money is rupees 2500 more than A. Okay, but this kind of for the comparison where there is a less difference or the window for the two quantities is lesser, you can compare them by subtraction. But when the window is more, means the difference is more, the comparison becomes a little inconvenient, or let's say it is not that much representable, or let's say a scooter's cost is say a scooter's cost is rupees say 50,000, okay, and a car's cost is say rupees 4,50,000. Okay, so if I say compare the price of these two, it becomes really not a very good way or a proper way to compare the prices of the two by subtraction method. So what we can do here is, we can say this is the scooter, this is the car. So you can say that the scooter is 9 times the car is 9 times the price of the scooter. Oh, that is the car's price is 9 times the price of the scooter. So this makes sense. A very good way of presenting the relationship. Okay, the comparison. So what is this way? How did we express this? This way was done using the division method. So comparison of two quantities can be done either by subtraction or by division. This comparison where division is involved, this comparison is called ratio. That is when two quantities or more quantities of the same kind. What do I mean when I say same kind? That is, the quantities that we are going to compare, they should be belonging to the same category. Now what is category? If the first one is of the category length, the second one should also be of the category length. If it is of mass, both should be of mass. If it is of money, both should be of money. Means the two quantities or more quantities that are going to be compared, they should be belonging to the same category, and positively they should be having the same unit. Now what do I mean when I say same category and same unit? Some will say, ma'am, same category means they will have same unit. Not necessarily. Suppose the length of a particular rod is say 1 meter and the length of another rod B is say 80 centimeter. both of them belong to the same category. What is the category? The same quantity, that is length. They belong to the same kind, that is length. But there is a difference in the units. So we have to make sure the two are converted to the same units. Only then the comparison by ratio can be done. That is, you can either convert this to centimeter or this to meter. Usually we convert the bigger unit to a smaller unit. In that case, the comparison becomes easier. So, if two quantities A and B have to be compared, what is the first thing that you have to keep in mind? That is, the two should be of the same category. That is, they should be of the same kind. Secondly, same unit. And then the comparison is done. So, we say the comparison of A and B, we represent it in the form of A by B, the fraction A by B. It is written as ratio of A to B. That is A by B, which is also represented in the form A, then we have two dots and then B. Okay, so this is read as A is to B. So this sign is standing for is to. So A is to B. So how you will read this? A is to B. Alright. That is, let's take an example. Suppose I want to compare 1 meter to 80 centimeter. So the first thing that we are going to do is convert this. So 100 meter, we are going to compare this to 80 centimeter. So how you will do it? So 100 by 80, that is 5 by 4, that is equal to 5 is to 4. Remember, this by sign is replaced with this is to sign, and this is the term, the numerator and the denominator takes the first and second place. Numerator takes the first place, denominator takes the second place. So a ratio is actually this way represented. A by B you will find out, and then you will represent it in the form of A is to B. Now there are two terms for two quantities to be compared. There are two terms. Okay. The first term is also called antecedent, and the second term is called the consequent. Okay, the two terms, antecedent and the consequent. So some might forget, remember, first and second. So in alphabetical order, A comes first and C comes later. So A represents the first one and C represents the second one. So antecedent and consequent. Remember one more thing while doing ratio, that is when we find the ratio of two quantities, like we did for the previous sum, it was 1 meter to 80 centimeter. We got 100 by 80, that is 5 is to 4 we got. Remember, ratio will not have any unit. Does not have. Does not have any unit. It doesn't have a unit. Ratio will not have a unit. Why? Because the ratio is here. The ratio, while you're finding the ratio, the first term's unit and the second term's unit, they are getting eliminated. Okay, while you're doing the division. So, ratio, final answer is does not have any kind of unit. So let's take some examples. Say 4 grams to 20 grams. So 4 by 20, that is 1 by 5, 1 is to 5. So 4 grams and 20 grams, the ratio of 4 grams to 20 grams is 1 is to 5. Remember, when I say 20 grams to 4 grams, it becomes 20 by 4, that is 5 is to 1. So these two are two different things. Here 4 grams to 20 grams is 1 is to 5 and 20 grams to 4 grams is 5 is to 1. So 1 is to 5 and 5 is to 1 are not the same. Just as how A by B is not equal to B by A. That means A is to B is not equal to B is to A. Remember this. Alright, because ratios are nothing but fractions. Okay. So just as how fraction and its reciprocal is not the same, similarly here A is to B and B is to A are two different things. So A is to B means the first term is A and second term is B. In this case, the first term is B and second term is A. So be very careful about what is to what is to what is to what. The first term is what and second term is what. The first term takes the first place, the antecedents place. The second term takes the consequence place. So be very careful when you are placing the term. Alright. If you are asked this and you give this answer, then you get a 0 over there. Alright. So be very careful. Let's do some sums based on this. Let's say 8 months to 2 years. If this is the question, find the ratio of 8 months to 2 years. So you can see both belong to the category time, months and years, but they are having two different units. If the units are same, you need not make any kind of conversions. But if the units are not the same, then you have to make sure that you convert both the terms in same units. Either you can go from months to years or years to months, but going from years to months make your calculation easier. So 8 months is to 2 years money, you have to do 12 into 2. Why 12 into 2? Because 1 year is 12 months. So 2 years is 12 into 2. That means you have to find out 8 by 24. That is 1 by 3. Your answer is 1 is to 3. So the ratio of 8 months to 2 years is 1 is to 3. Secondly, if I give you a sum, say 300 grams to 2 kg. So both belong to mass, but units are different. So this becomes 300 to 2000. Why? I have converted the kg to grams. So 300 is to 200. So this is 300 by 2000 or 3 by 20. Your answer is 3 is to 20. Alright. So make sure that whenever the units are not the same, you are converting them to same unit. So for 200 grams to 2 kg, for this ratio your answer is 3 is to 20. Now, if in case of this we would have had 200 grams, then we didn't have to do any kind of conversion. So 300 by 200, that is 3 by 2. Your answer is 3 is to 2. That's all over here. Alright. Now certain points that you need to remember, that is, suppose there is a ratio A by B. If you multiply with a non-zero term, what did we multiply here with? A non-zero term, that is MM, non-zero number. So that is AM is to BM. So it keeps this becomes an equivalent ratio of this. What that is, like how in fraction we studied that a fraction whose numerator and denominator is multiplied by the same quantity does not change the fraction. Similarly in ratios, if the terms of the ratio is multiplied by the same non-zero number, then the ratio remains unchanged. Similarly, division also you can do, say okay, A by M and B by M. So this and this, they are also equivalent. So if I say two is to 3, so 2 by 3, if we multiply with 2, numerator and denominator to both, then we get 4 and 6, that is 4 is to 6. So we can say 2 is to 3 and 4 is to 2 is to 3 and 4 is to 6. They are the equivalent ratios, means they are not changing. So the terms of the ratio can be multiplied or divided by the same non-zero number. All right. Okay. Now let's come to some sums. Okay. Sum number 1. Let's say find the ratio of 250 gram to 1 kg. Number 2, 90 centimeter to 3 meter. Take some time, finish it off quickly. Come on, we'll discuss the answers. Most of you have done it orally, I know. The first sum, 250 grams is to 1 kg. So you can see both refer to mass, but units are different. So this is 1000 grams. So this is 1:4. 250 by 1000 is 1/4. So answer is 1:4. Second, 90 centimeter is to 3 meters. 3 meters means 300 centimeters. So this is 3:10. So I'm sure you have understood this, how to find the ratios. So for the first one, we got the answer 1:4. What did we do? We converted the 1 kg to grams. So 250 is to 1000, that is 1:4. We got the first answer. Second one was the same thing, 90 centimeter to 3 meter. So the meter had to be converted to centimeter. So say 900 divided by 300, which when you do, you get your answer as 3/10. So you have to reduce. Remember, whenever you are given a ratio, we always express the ratio in the lowest terms. Like how, suppose a fraction is given 14/20. What do? We immediately reduce it. How do we reduce? I need not explain how the conversion of a fraction to its lowest terms is done. That is, you divide the numerator and the denominator by the HCF of the two. So here HCF is 2, that means 7/10. The same thing goes over here. So if you have a fraction 14:20, you also have to convert it to the lowest term. That is, this becomes 14/20, that is 7/10 or 7:10. Alright, so this is the difference, the representation. Otherwise, the entire thing goes how we go ahead with fractions. The working, the process, everything is just like fractions. Just the writing is a bit different over here. Is to sign given, but the working remains the same, just as fractions. Okay, so always a fraction, always a ratio has to be converted to its lowest terms. By lowest terms, what do we mean? Just as what we meant for fractions. So whenever a fraction was given, we had to reduce it to the lowest terms by dividing the numerator and the denominator by its HCF. Similarly here, for the case of ratio, we have to divide the first term and the second term, or let's say the antecedent and the consequent, by the HCF of the two terms, and then we get the reduced ratio. Okay, the reduced in its reduced terms. All right. So I hope the basics of ratio is quite clear. We had just done the basics or the starting or the introductory part of ratio today. We shall go ahead with this lesson in the next class, following more examples, making the concept much more clear. So till then, me waiting for you to comment your doubts, your problems in the comment section. If you like the lessons, please do like the channel, subscribe, and also don't forget to share. Meet you very soon in the next video. Till then, bye bye.